Okay, this is number 37 on 3.4. This is a kind of a complicated one because we have to use our calculator a bit for these because this thing doesn't work out evenly. So first of all, they ask you, it's kind of a loaded question because there's a lot to it. Describe the motion of the particle for t greater than 0, and they give you the position function. Now this is on the line y equals 2, so the y coordinates are always going to be 2, it's just the different x's. So what I did was I put this into my calculator. Now you can see I got both functions, but I'm just going to highlight the velocity, and I want to see where it's equal to 0, so I go to graph, and there's my velocity. I can go to second calculate, and then I can go to 0, enter, left bound, oops, enter, right bound, enter, and I get this, and I'm going to put this in second quit. Remember, we can store this in alpha A. I'm sorry, I put store. Store, and then I go alpha A. Hopefully I got it. Yep. All right. So that's one time when the velocity is 0. Then I go back up here to graph again, and I'll go to second calculate, and then I'll go to 0 again. Enter, and then I'll try to find the other 0. So I'll go over here. Left bound is right about there, and the right bound is there. Enter. And that's going to be my second 0, and that's 3.18, so I'll store that. Store, remember store. And then we're going to make that alpha B. Enter. That's where we use a little storage button down here, remember store. Down there, stone. Okay? So we got those values in. And now what I'm going to do is I'm going to try to find the position where I'm at when I'm stopped, so I can describe the motion. So I go back to Y, and I'll turn this on. So I got both these, and then I go to var y vars. And this is going to be the position function. Oops, sorry about that. Mess that up. Go to var, y vars, enter, enter. I'm sorry, I got to go second quick. Pardon me. Then I go to var, y vars, enter, enter. Then I put a parentheses and alpha A, so I can find out my position at alpha A. Now let's go back here. Sorry about that, second quit. Go alpha A, parentheses. And I got about 6.14, so my position was about 6.15. So this is my position, and when x is 1.15 seconds, that's 1 second. We'll put past 1 second. Then I go to second enter. I go back over here, and I make this alpha B. And I press enter. And I get minus 2.18. So that's my position at 3 seconds, all right? And then I got to see what happens at 4 seconds if I want, or 5 seconds, and it's going to go to the right. But I can always check I can just go back a second, and let's say 5 seconds, enter, and 30. So I'm going to the right pretty fast. So you can kind of see what's going on. So using my calculator and finding these values, so I just wanted to show you how to do that if you forgot. Mess that all up, okay. So basically what's happening, so what I figured out was, and x is 0. The 0 position is easy to find because if I just put 0 in here, I know I'm at -5. So basically I start at -5. I go 1.15 seconds, and I end up about 6.15, a little bit past 6. Then I stop, because that's when my velocity was 0. And then I'm going to turn around because I'm going to head back this way because I'm going to end up after 3.18 seconds at -2.18. So I got to be going left. From 1.15 seconds to 3.18 seconds, I'm going left. And then I stop again because that's where my velocity is 0. And I turn around and I head right. And I keep going. Okay? And I checked over here, and I used the velocity function. I put some values in the velocity function. I've found the velocity after 4 seconds was 14, so it keeps going, so it's cruising. Okay? And you can check these other things. So that's how you did the first part. That's how you did A. Okay? So I hope that makes sense.